Hey, welcome to Innovate Africa, and today we're going to discuss space-age technology developed by a South African company which should be used in our schools to give our learners the leading edge, on the cutting edge, so to speak. At the moment, learners in the United States are using this technology more prolifically, and I'm really hoping that South African authorities catch a wake-up call and start embracing this tech. What am I talking about? It's called MaxIQ. Bjarke Gotfredsen, thank you very much for joining us. You're the co-founder of MaxIQ. What business exactly are you in?
So we are Edtech business. What we do is that we are developing technology, as used a broad term, to assist schools primarily to educate students in science, technology, engineering, and math, STEM. So our business is to get out there to as many schools in the world, and mainly high schools, to get the students to focus on STEM education into the future. That's our main purpose with MaxIQ.
Tell us more about your evolution story and how you actually grew to becoming a business that sends payloads into space.
So my business partner and I, we started with enterprise development for a number of international companies here in South Africa. And these companies had one of them specifically, which was Isuzu Trucks, had problem finding candidates, engineers, to work in the factories here in South Africa. So what they have done is that they had come out with bursary scholarships to get students to study the engineering fields that was required. But the students come out of the high school doesn't come out with a qualification that's good enough to take up these bursaries. So we found out that together with the Isuzu Trucks, there is a gap between all the bursaries that's actually available and enough students that have enough, that have qualified enough grade-wise from high schools to actually be able to study at the university. So we together with Isuzu Trucks started out with trying to come up with a plan to get into schools and get them to study STEM. And we decided to focus on space as an inspiration. And we actually, back when we started this business here, bought the first privately owned satellite and launch in Africa. Now, it was cheap, it hasn't launched yet, but we since have been in space many times. Back then, when we did this thing here, we then realized that we didn't know a lot about space, so we have to figure out this concept here. And then we found a university in the US that also had programs where they tried to get high school learners to study into the university, so-called feeder schools to the universities. So we took one of those programs, implemented here in South Africa. We had trucks that was kind of like developed into mini labs, drove around to a lot of the different schools, especially here in the Cape Flats, and we were focused initially only on girls, so women in STEM. And we ran that program for a year, but the technology was very outdated. It was analog. It was soldering, and what we found is that the student could solder something together, and that was it. You know, that couldn't really take anything away that they could continue working on. And for us, it was important that when we've been to a school, that we could leave something that students could keep working on. There's a lot of this kind of technology where somebody comes out to a school and shows something and then take the whole thing away, and the student is like, okay, that was a fun activity. But we need them to kind of be able to continue. So one of the things that was important for us was coding. And coding is one of those things that if you have, you know, apparatus to code on, then you can just keep coding. It doesn't cost more than a little bit of electricity to your computer. So we wanted to use this technology here where they could put something together and they could code it. And we also wanted to make sure they could have like an out-of-box experience. Even if they didn't have access to a computer, they could still use it like an instrument. So that was how the technology started. We then decided to take it to a conference in the US, and it was met with such a fantastic, let's call it applause, that today 95% of all our turnover is actually in the US. We don't do much outside the US simply because US schools, universities, and even lower grade schools are using this thing here to teach their students STEM, all kind of STEM subjects. So that's how we started.
So we've spoken about this in generic terms, but can you be more specific about the type of technologies that these young people are actually using?
So the reason why we specifically developed this technology was not for the US market, but for the African market. So these are small PCB boards, small printed circuit boards. They're like 30 by 30 centimeters, so millimeters, so very small. They actually follow the standard of Lego. So they're 4 dots wide, if I can use that term. And you can click them together with your hands. You don't need a screwdriver or any kind of equipment. So these chips comes in different module styles. So there's some input chips like typical a sensor. There's some output like a display. There's some programming chips like a little computer chip that you can program. And there's some power chips, either battery or something you plug into a USB port. So you click these things here together. And when the student first started, it's already loaded with some software, so it can already show result on the screen and things like that, which a lot of the schools like because they can not only just look at it from a coding perspective, but they can use it straight into math or physics or chemistry or whatever other STEM subjects they want to teach, where they can use this and as an instrument. So the starter kit comes out with like a weather sensor, give you temperature, humidity, that kind of stuff. There's a light sensor that gives you like light levels. The new one gives you like, it will tell you what color something is, simple things like that. But then you can expand it with an accelerometer that gives you acceleration in X, Y, and Z. So, which is interesting if you, for example, put in a high altitude balloon and want to know when it pops, or you really want to know if the International Space Station is in microgravity and so on. We're coming back to that later, I think. But there's also there's a CO2 sensor that measures the gas. There's particle matter sensors. There's barometer that measures the atmospheric pressure. So there's a lot of different others. And then there's on the output side, yes, we have the display, but it's also Wi-Fi connected. So we'll upload data to a dashboard so they can participate in collecting data on a grand scale. There's also mechanical stuff like servo controllers and things like that, so you can build some robotics. The way to look at it, and this is our focus, is that we look at our modules as the computer electronic answer that 3D printing is to mechanics. If you have a 3D printer, you can print any kind of physical material, depending on how good your 3D printer is, of course. And the same with our electronics here, you can actually click something together. The way to look at it is that imagine you went to Mars. One of the first things you want to take with you is a 3D printer, because if something breaks there, it's going to take 4 years before you get it again.
I'm also really interested in finding out more about how these technologies are actually used by learners both here in South Africa and abroad.
I take, for example, one of the schools in Cape Flat, Sonica High. When they started using the kits, they learned how the sensor works. They learned to program a little bit. Our low-level part of it, they can be programmed in something called MakeCode, like microbit stuff. So they learned a little bit of that. And then one of the sensors we have is a soil moisture sensor. And they got very interested in that because they wanted to do some agriculture. So they actually now started looking at the weather patterns using the weather sensor and the soil moisture to figure out when they have to water and things like that. So even though agriculture is not necessarily seen as a STEM subject, I mean, you're out there with a rake and a tractor. But today, agriculture is very much a STEM subject, where you are using drones to survey your fields and spray them. The tractors are robotic programmed and running around. And agriculture is, of course, important for us still now, as long as we are here on this planet. And what's important is that we get students who are still interested in this thing here. And they will be interested in it because STEM is also interesting in agriculture. Now, we have another school talking about agriculture in the US. They are part of a NASA project where they get sent lunar dust, so soil from the moon. Now, it's not the real thing because there's not that much of it, but they found a simile for that. So they get sent that. And then the school participate in a program where they have to try to grow something in this lunar dust. And of course, the whole idea is that whatever they can get to grow in this thing here, we can grow in an artificial atmosphere, of course, under like indoor, but not bringing the soil to the moon, using the regolith days on the moon already. So they're using that, and they're using the same sensors because, yes, it's kind of like a different soil, but they still have to be moisture, hold water, and things like that. And then it's moon, and of course now that's super interesting, but it will also be interesting for Sonica, who heard about this thing here and say, wow, you know, we can really introduce space back into this thing here. Wherever the humankind goes, we have to have food with us and we have to grow it. So that's, one of them. The other example is that we have these balloon flights. So schools can do what we call a low altitude balloon flight themselves. So blow up a very big party balloon that's like a meter in diameter. And then our technology, one of the chips is a GPS, another one is a long range radio. So you can click this together and then you can build yourself a ground station. And the software ready-made, so you can actually just install it. And then you can fly a balloon and track where the balloon flies. And in the meantime, it will have maybe a SD card on board, and it will have the number of sensors and will record what it observes. So we had a school that flew on a high-altitude balloon with NASA, and they had a gas sensor on board that measured a number of different volatile organic gases. And normally you wouldn't measure that high up in altitude because they're heavier than air, so they should not be there. But they measured some. And then they used that to figure out that, hey, there is a volcano in Alaska that actually had smoke going through the jet stream coming over that area. So they could use that to map it. Now, the school, after this flight where they didn't think they will actually learn something new, documented this thing here. NASA have now asked them to present papers on this thing here, and they're just a high school. But the thing as a teacher told us is that now these students feel way more confident because they're now presenting to industry.
Now, while this has caught on internationally, this is a proudly South African product. It's conceptualized here, a lot of work, most of the work is done here. Take us through the role that South Africans and your South African business plays when it comes to bringing all of this to life.
So all our technology is developed here in Cape Town in South Africa. When I say all our technology, it's all design of the hardware. Every single piece of the hardware is local designed. All the software is programmed here. All the server setup is done from here. All the learning materials, student sheets, learning sheets, exercises, running the learning management is done here. All the customer care, customer support is all from here. So MaxIQ is a South African company. Yes, we sell in the US because they wanted it. And we're not saying no to dollars. We are also selling in South Africa and in the rest of Africa. We have customers in Cameroon and Cote d'Ivoire, in Nigeria. We've done stuff in Kenya and of course here in South Africa. We have many times when we also sell, we have organizations who want to run a program, so they pay us to run this program using our technology. So, such as Intelsat, who has done a program across Africa. So we have had students across Africa, part of a program like that. We've done it with UNDP, United Nations, and UNICEF, two United Nations organizations, also again here in South Africa. So we have a number of different institutions and schools and things like that, but still the way that the Americans are organized, where the NASA is actually funding quite a lot of education, there's a lot of money for that kind of stuff over there. Now, while everything is developed here, it's not everything that's produced here, but all the manpower that's needed to do this thing here is actually here in Cape Town. So while we have stuff produced outside, it comes back after a robot had put it together. We literally send a production file overseas, and we get like panels back that no human have touched. All the Q&A is then done here. We have apparatus here where we have people sitting with the apparatus and testing every single component. They're then packaged here and warehoused here, it's stored here. So every single element of running this business where there is human capital required is done here from Cape Town. In Fontaine, they are busy setting up satellite dishes, I think 6 of them, for the lunar mission. And that's funded by NASA. So NASA is building in Fontaine and a similar way in Australia. So as the Earth rotates and therefore face the moon, they can then get the data as we send astronauts back to the moon. That project in Fontaine, NASA required there was outreach and school was involved. And the South African delegation said to NASA, well, you have to help us, what should we do? And NASA said to them, well, we use your guys in the US for this. And Westgrow then, who is responsible for the outreach, then contacted us. I believe you do outreach in the US, can you do it here also? And I said, of course we can.
Now, Bjarke, finally, let's talk about the stories that you, your partner, Judy Sandrock, your partner in this business, the stories you'd like to tell in 3 years from now, but also throw in some of the stories that you already can tell.
Maybe I should start with some of the stories we can tell already. Our technology have flown on over 50 satellites. So we actually have space heritage, which is called when your technology have proven to work in space. And that was a number of student satellites that flew from the US. We have been on an International Space Station twice. We're going up again next year. Our local space agency have taken our weather station and run it as a weather station on Antarctica. So we had a lot of this. NASA have an organization called SETI, Search for Extraterrestrial Intelligence. Yes, it's a real thing. And they're in California. And they actually don't search for intelligence, they just search for life. And they're taking our technology to the Andes Mountain in South America, which is an analog for how Mars was 3.5 billion years ago, and try to use that to see if they could have a low-cost life finder, so to speak, that could use on Mars and the Moon later on. So we have a lot of interesting ways it's being used. Princeton University have been using it since 2017. During the lockdown, Stanford University used it for all the students in both undergrad and postgrad, simply so the student have a technology could take home and work with since the lab was closed. So we have had it used a lot of different places, and a lot of these places, of course, still using it after lockdown. But we have a lot of different success stories here and there. For us, and for me, the story I want to kind of tell is hopefully a story I don't have to tell, because it tells itself, that everybody know in 3 years' time what MaxIQ technology is. Little they know maybe what Raspberry Pi or microbit is. Not necessarily as well as Lego, which has been around for much longer. But at least if we can get a name recognition on a level with Raspberry Pi or microbits in 3 years' time, that will make me very happy.
Well, there we go. Thanks again for watching Innovate Africa. A great example of the power we have as Africans. Space grade, cutting edge technology developed on this continent that people around the globe are clamoring to get their hands on. We are worth it. We can do it. We are doing it. Let's believe in ourselves. I'll see you next week on Innovate Africa.